When comparing numbers in different bases, we have to refer back to the knowledge that we already know about our base 10 pieces. Our base 10 pieces represent that every 10 that we have, we regroup and move to the next place value. So if we have 10 ones, we regroup that and exchange it for like a long piece to represent a 10. And then once we have 10 longs, which would be 100, that would move over and be exchanged for a flat in the 100 spot. So how we know that is that our 1 spot represents 10 to the 0 power, and then the 10th place represents 10 to the 1 power. And the way that we know that is that if we have 10 to the 0 power, that's nothing. So then if we had like a 7 here, that would just represent 7 because we're not taking that 7 times anything. If we had 10 to the 1 power, that equals 10. So then for our 10th spot, we have 10 times whatever. So then if the 7 was in that spot, we would take 7 times 10, and that would be 7D. So this represents the 70th spot in that case, and so forth and so forth. So if we have 10 squared is 10 times 10, which is 100, and 100 times 7 would be 700. So the number represented there would represent the hundreds. So we do the same type of thing when we are working in other bases. Now we have 3, 6, 2, base 8, and 1, 4, 3, 4, 5. Base 5 there. So we do the same thing. When I do this, I always write the exponents above the number that I'm working with. So this is 8. So the first place value here would be 8 to the 0 power. The second one would be 8 to the first power and 8 to the second power, since we have 3 numbers. So like we said, 8 times 0, we don't do anything there, so it represents just 2 by itself. So we can add the 2. And then we have 8 to the first power. So 8 to the first power is 8. So then we take 8 times 6 and we get 48. And then we have 8 to the second power. 8 to the second power is 8 times 8, which is 64. And 64 times 3, the amount that we have in the place value, is 192. We have those 3 numbers figured out now, so now we just need to add them. So I get 242. So that represents, this is the 242 number in base 10. And then for this one, we do the same thing, but since we're working in base 5, we're going to have like 5 to 0, 5 to 1, 5 to 2, and then 5 to 3 for this one. So I'm going to fill those in. And then working with the same steps. 5 to the 0 power, we don't do anything there, so this just represents 4 by itself. 5 to the first base is just 5. 5 times 1 is 5, and then we have 3 of those, so it's 15. 5 times 3. The next place value is 5 squared. We have 5 squared, so we take 5 times 5 is 25, and we have 4 in that place value, so it's 25 times 4, which would be 100. And then for our last spot, it's 5 to the third power, which is 5 times 5 is 25, times 5 is 125, and we have 1 in that place value, so we're going to add another 125. Once you have all of those numbers lined up, then you're going to add them all together. And we get 244. So then when we look at these two numbers, we can say that 362 base 8 and 1434 base 5 are not equal. And this is the number that it represents in base 10. So ultimately, this base 5 number is bigger in this situation because we got it down to 244, and 362 base 8 represents 242.